Okay, hi, my name is Sharif Muhammad, back again with an update on my FYP2. So, my topic, the recommendation system. This is the implementation of recommendation system using collaborative filtering, and for this time, the similarity metric that I used was cosine similarity, right? So cosine similarity is like it calculates the cosine angle between two sets, which is the user profile vector and the set of listings, right? So I used cosine similarity, and I also used like Jagged similarity just to reflect and just to show the distinct recommendations that I get from both, since these are uh, these are different similarity metrics, because cosine similarity is the cosine angle between two sets, and Jagged similarity is basically the intersection of two sets over the union of two sets, right? So I'll start with Jagged similarity. So I've implemented Jagged similarity here, Tanimoto coefficient, which is also like Jagged similarity coefficient, like they just one and the same name. So here I run it again. Uh, I run it again. So what it's supposed to do is like it's supposed to print out uh, all the all the data that was filtered out from the API. Since I'm getting my data from the API, as per this fetch function, I'm fetching data from um, from Airbnb 13 API, right? So it prints out the set of listings that are relevant to the data, and at the end it gives like the top 10 recommendations, so which means the system recommends the below options, and these are the options. This is based on the Jagged similarity, which is the intersection of two sets, which is the user profile and the set of listings, over the union of both sets, right? So here I've tried to also write down like the similarities, how similar like these pair of listings are to to the target listing. Okay, then for cosine similarity, I implemented it here. So cosine similarity, as I said, is the cosine angle between two sets, which is the user profile vector, the user profile set, and the set of listings. Okay, so I implemented it here as well. As you see, I was using the math.square root, which is like the square of like the vectors, right? The square of the magnitude 1 was for for set 1, and magnitude 2 was for set 2, right? And then uh, we just return the dot product of both sets, the dot product of both vectors or both sets over like the magnitude of vector 1 times the magnitude of vector 2. That's how we get the similarity score of cosine similarity. So if I run it, okay, node trial.js. If I run it also, it's supposed to print out the listings from from the from the filtered API data, and also give us the recommendations. So you'll see that starting from here, the system recommends the below options. It shows us like all the recommendations given by the system, based on cosine similarity. These are all the recommendations. Okay, and this data is saved to the database, because I was also using MongoDB for this data. So both these are content-based filtering, just to show that um, just to show the variation or the difference and the intersection of data between, cosine similarity and Jaccard similarity. And then for this one, I implemented this one using collaborative filtering, which is based on the idea that users who've shown that they shared a similar interest in the past, those users are most probably going to share the same preference again or the same interest again in the future. So which makes them like neighbors or like similar users. So based on that, I had to create like a set of testing data in the MongoDB, like database, because the data I was getting from the API is not the type of data that is fit for collaborative filtering. Hence, I took the data from the API and wrote a program. I wrote a program to kind of turn it into a user item interaction matrix. So in this program, when I was calculating like user similarity for this one, I used the Pearson correlation. Pearson correlation, it shows the linear correlation between two sets, right? So based on from this similarity, what I first did was I made a user matrix where the rows represent the users and the columns represent the items. So and in these matrices we have like values that are inside which show the similarity, which show the interaction strength between the user and the items. So based on this also, I also got uh, I also got recommendation results based on this, and the recommendation results are stored in the database. They're not for this one, they're not printed to the terminal, but like they're stored in the database. And then for my thesis writing, here is everything. So mainly for my methodology, I've reflected how I've implemented these techniques, because these techniques are all in all a part. They are all like subparts, because they are all supposed to lead to a hybrid recommendation system where I combine both results from collaborative filtering and content-based filtering, so that I get a wider range of results. So this one is a recommendation system based on Jaccard similarity. The steps, of course, are data collection, which I collected from the API, and then feature extraction, which is using the TF-IDF, which is term frequency inverse document frequency, whereby I get like the uh, where I get the data, and like I I try to like measure or count the number of times that certain words, or like that all the words in fact have been mentioned in the document, and okay. Then I also use like similarity calculation. This one I used, of course I used the Jaccard similarity, and then yeah, the recommendation algorithm, it contained name, city, or these are like, this is the data set, the filtered data that I took from the API and filtered to just leave the things that were like relevant to the system. So the first one, of course, is with similarity. Okay. And then technique 2 is with cosine similarity. So of course, as you see here, this is a cosine similarity. Like I had to first import like certain libraries, so that to make this possible and to implement it in JavaScript, and then I pre-process the text using a method that I wrote, which is to remove like capital letters, which is to remove like any punctuation in the document or whatever, so that the data is uniform and it's easier to process. Then cosine similarity, of course, for the similarity metric I use cosine similarity. Then I also use mongoose to store the data that I fetched from the API. And then TF-IDF for like data extraction, similarity. And then from the similarity metric that I used, I got the similarity scores, and then we got like the recommendation. Technique 3 is using collaborative filtering. The database schema was whereby I created a simple testing data unit, so that I could test my recommendation system using this testing data. So after that testing data, I used that data like from the database, from the MongoDB database, to create a user metrics that shows like user item interaction between users and items. And then for similarity calculation, this time I used Pearson correlation coefficient, and then I got the recommendations based on the similarity scores. Then all this as well, I combined like the results from content based and the results from collaborative filtering to get hybrid recommendations.